All right, so piecewise functions are functions that take different smaller parts of functions and put them together. They're pieces. That's the name. So it looks like this. They'll have a little curly brace thing, and they'll have some function. We'll call it part A. And then they will have their if, and then put the domain. And then they'll have another part. If, and then the domain for that part. And then they might have another part. Technically, they could have as many as they wanted to, but and then they'll have another domain for that part. Okay, so what happens here is the domain for the entire function is the collection of all of these domains out of that. So you've got many domains inside of the bigger thing. So we've got pieces that make up the whole function out of that. And I need to take the Christmas decorations down, I guess. Notice they were still up. They're still up at my house, so it's okay. Kids love them. My wife loves them, so everybody's happy when they come home. It's Christmas every day. So. All right, so let's look at just some examples of these. So what we're going to do is we're going to mix in some of the other functions that you already know about that you've dealt with. So we will have some parabola pieces in here. We'll have some linear equation pieces. Might have some absolute value function pieces out of that. So we got to remember what those graphs look like, so we know kind of what our picture is going to do, so we don't have to plug in as many ordered pairs out of that. So let's start with a fairly easy one. And we'll just do linear pieces on this one. 3x plus 2 if x is less than negative 2. 6 if if negative 2 is less than or equal to x is less than or equal to 4. And then negative 2x if x is greater than 4. Okay. So what this says is that this graph or this function looks like 3x minus 2 as long as the x's are less than negative 2. Okay, so that part of the picture looks like 3x plus 2, which we know is a line with a positive slope. So we know it's going to be doing this from negative infinity up to negative 2, right? So what we need to do when we're looking to graph that piece is we need to know where what's the y value when x gets to be negative 2 for that particular piece. And I call these just important points. There's no real mathematical term for that. Critical points, important points means the same thing. So what we're going to find is ordered pair for that particular function at negative 2, even though with that particular domain, is negative 2 included? No, but we still need to know what's happening there with that particular graph at that point. So I'm going to plug in negative 2 into that function. So what's 3 times negative 2? Negative 6 plus 2 would be negative 4. So that particular piece, when I go to graph this thing, I'm going to go down here and draw myself a little coordinate plane. About a 10 by 10 is plenty big. And I'm going to go to that point, negative 2, negative 4. And I'm going to put an open circle there. Why am I putting an open circle? Because the negative 2 was not included in the domain for that. Now, here's where you've got to think a little bit here. It says the domain is for all x's that are less than negative 2. So which direction is that going? Left or right? Just say both and you got it right. Left and right. No. It's going to the left because all the x's are where? Less than negative 2. So the x's are less than negative 2 or negative 3, negative 4, all the way to negative infinity, right? So what does that graph look like going to the left? It looks like 3x plus 2, which is a slope, right? So I could go down 3, left 1. and get that picture happening there. Because it's a slope-intercept form of a graph, I can follow the slope to get there. Here's the beautiful thing. You don't have to follow that. You could plug in the x values that are less than -2 and get those ordered pairs. If I plug in -3, that's -9 plus 2, which is -7. And that's that point right there. If I plug in -4, I get this point here. If I plug in -5, if I needed more, I could get the picture out of that by just plugging in x values. But that's our timer on our quiz. You guys finished early. So if you want to plug in points, that works. It gets you the picture. If you know what the picture looks like already, it's a little faster. So that's the idea of the slope thing. So we're going to draw that line. Should it have an arrow on the end of it? Why? Because it's less than -2, and that goes, it doesn't say it stops anywhere there. So it goes all the way to -infinity there. So that's just the first part. Now we got to graph two more parts. So I'm going to go up here to my function, and it says f of x is equal to 6 from -2 all the way to 4. So that one has how many important points? 1, 2. It's got two x values there in that domain, right? So I got to have a starting spot and an ending spot with that. So, but there are no x's in my function. So when I plug in -2, what's the y value? 6, always. When I plug in 4, what's the y value? 6, because it says y equals 6, no matter what. But the domain there says that only happens from -2 all the way to 4. So I'm going to go to that point, -2, 6. And I'm going to put a filled in dot. Why did I put a filled in dot? Because it's included. It has an equal to mark on the inequality symbol. And then I'm going to go to 4, 6. Put that. What do we know about the graph of y equals 6? Horizontal line right there across, connecting those two dots. It's nice when they're starting and ending points. It feels like you have a beginning and an end there. Okay, so we've graphed the second piece. Third piece happens for all x's that are greater than 4. So it's got an important point at the x value of 4. So we're going to plug that into the -2x. -2 times 4 is -8, right? So I'm going to go to the point 4, -8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so what am I putting there? Why open? Doesn't have the equal to mark, so an open circle there. And then it looks like -2x, which is what? What kind of shape? It's a line, right? Goes down and to the right. Slope is down 2 over 1. How else could I get those points that I just drew? Put in any number greater than 4 and get the points out of that. Good job, Wayne. And we get the graph. So from that graph, we're going to talk about the domain, the range, the intercepts, and then this new thing called continuity. All right. So I've got that picture drawn. I don't technically have to have the picture to get the domain. Picture's really handy to get the range. But the domain I can get from, because the domain is spelled out for me over there on the right-hand side of my function, right? So what is the domain of this one? So as we were graphing that, the blue line is the one we started with. That was the first part. Where's it start? For domain, we read left to right. It starts at -infinity and goes all the way up to where? -2. So we're starting at -infinity. We're going all the way to -2. And then this one has an open circle on it. Does -2 get used anywhere else? Where at? Right there, right? So is -2 skipped or is it used? It's used, so we're not skipping a number. So we went from -infinity, we're at -2, we keep going to the right, we get to here, that's 4. Is 4 used? Yes. And then we pick up from here. And this goes to where? Positive infinity. Did we skip any numbers? No, they all got used in one of the pieces. So that's from -infinity to positive infinity. All real numbers, whatever you want to say there. That's the domain of that. Okay. Now let's look at the range. How do we read range from a graph? Bottom to top. So both the blue piece and the green piece are pointing down. So that means our range starts where? -infinity. And the green piece stops here at -8 is the y value there. But is -8 used somewhere else? Right here. Right? So it's covered up. It's used. So we're not skipping it. But this one stops where? -4. Does anybody else use -4 as a y value? No. So we are skipping some numbers there. So we're going from -infinity up to -4, parenthesis. What's the next y value that gets used? 6. Any other y values get used? No, 6 is the only one. So that's how we join that range together. It doesn't have arrows pointing up, so we're not going on to positive infinity. It's that flat line there. It's that constant interval piece there that only has one y value. It's a 6. So that's our range. Intercepts. Where's that graph crossing either the x or y axis? 0, 6, right? That would be our y-intercept. Are there any x-intercepts? No. Where did that y-intercept come from? What part of the piecewise function? It's that middle piece of the function. It's the highest line that we drew, but it's the middle piece of that function. And look at the domain. Where does 0 as an x value fit? It fits in this domain here. That's the only piece that a y-intercept could come from, right? Now, x-intercepts are a little more tricky because you got to look at where y is 0. This one doesn't cross the x-axis. The graph is really handy to find x-intercepts with, but the y-intercepts you actually could find from just the function by just plugging in out of that. Plugging in 0 into the correct function. All right, let's talk about continuity. Continuity has to do with something being either continuous or discontinuous. If something is happening continuously, what does that mean? Keeps going forever. It what? Doesn't stop at any point, right? So continuously, your heart beats continuously, right? So no, it doesn't stop, or I hope it doesn't. If it does, we got problems. Okay, look at this graph. Does it ever stop? Well, if I try to trace that graph with the highlighter here, I've got to pick it up and jump up here, right? And then I got to pick it up again and jump down here to get it to do that. To me, that's stopping, isn't it? If it were continuous, I would be able to take my highlighter and just, flow right through the and never have an empty spot. This one, we had to pick up the pencil to move to the next piece. So it's called discontinuous. It's probably not the most mathematical definition of it, but the best way for me to describe continuous or discontinuous to you is if you can trace the graph without having to pick up your pencil, it's continuous. If you ever have to pick up your pencil to move to the next piece or skip a number, there's a hole in the graph, then that's a discontinuous graph. Okay, trace it with your pencil. If you don't have to pick it up to skip a number or move to another piece, then it's continuous. If you've got to move to another piece or skip a number, or there's a hole in the line, then it is discontinuous. Okay, so not a hard concept there. All right, let's go to a little bit more difficult function. Get the picture of it. Example B. We're not going to do many of these today. Oh, I forgot. I was going to show you how to do that with the calculator. I don't like doing them with the calculator, but it will do it, so I want to show you that it can. Just so you can check your graphs to make sure you did the right graph. All right, so graphing calculator, we're going to do the graph of a piecewise defined function. So go to y equals, clear out anything else you've got there because you don't need it. And then make sure your plots are not turned on. You don't have one of those plot 1, plot 2, or plot 3's darkened in. If you do, turn it off. Turn the plot off. All right, so first thing that I'm going to do is put in the first part of my function. When you're putting in your parts of a piecewise, you got to use parentheses, okay, around that part of the function. So the first part of the function was 3x plus 2. So I'm going to put parentheses 3x plus 2 and close those parentheses. Then I'm going to close that parenthesis or open up a new set. This is where I'm going to put that domain part. Okay, so I'm going to tell my calculator to graph that picture only when x is less than or less than -2. So I'm going to type x, and to get the less than symbol, we're going to hit second math, and this menu should come up. The test menu should come up. We want the less than symbol. Second math to get to the test menu, and we're picking option 5 there for the less than symbol, and then -2. And then I'm going to Y2, and I'm going to put in the second part. So parentheses 6. And this is where I've got to be a little bit more creative. Your calculator is not quite smart enough to deal with a compound inequality from -2 to -4, or -2 to +4. So you got to put it in as 2 of them. It's not real hard. You just put in -2, second math, less than or equal to x. And then we need to put the word and, because that compound inequality is an and inequality. So we're going to hit second math and then press the right arrow key 1 time. And there's the word and. And then we're going to put the other half. X is less than or equal to 4. X, second math, less than or equal to 4. And close those parentheses. Yeah, it's a lot. This is why I don't do it with the calculator. I'm much faster at just doing it with graphing paper, and because it just takes a while to get there. All right, let's get that last piece again. Parentheses -2x, and then open up another set of parentheses, and we just have to say x is greater than 4. So x second math greater than 4, and then hit graph. And you see the picture that we drew. Here's the lower piece, here's that constant interval part, and here's that little piece that we drew there. Get the same picture I drew by hand. It probably took, it takes me forever to type all that stuff in. But yeah, it'll do that. Yeah. What it does is it reads it as separate functions. It doesn't know that you're doing a piecewise. It can't handle a piecewise. It can handle, okay, the first function was only the x's here, and it says, okay, we're not using the x's greater than 2. So mine actually has the whole thing blue from here over, and then the whole thing red from here over, and then it's black from here to here. That covered up the blue part there. It's actually there. Mine had different colors selected for it. Yeah, and it just covers it up there. But we get the idea that your calculator can do that, so you can check your picture if you're not sure of that. I honestly would rather do it by hand, just because it's quicker. And that I can't really, when I hit trace to try a number, I've got to make sure I'm on the right part, because Y1 is the first part. And then to get to Y2, I got to press the up arrow key or down arrow, and there, now I'm on Y2, and then I get to Y3. So depending on where I wanted to get a value, I got to make sure my calculator's on the right spot. And there's too many things that could go wrong there. I don't generally graph these with the calculator, but it will do that. So I wanted to show you that it could, just in case you wanted to try to improve that. Maybe you'll one day work for Texas Instruments and you'll write a better way of doing piecewise functions for them. I'm sure there's somebody that's written an app for that. So let's do. All right, so we're going to graph this one. It's only got 2 pieces, which is nice. So important points. So for the first piece, we're going to plug in a 2. And what's the y value? 2 squared would be 4, right? So I'm going to graph this thing. I'm just going to draw myself a little graph over here on the right. 10 by 10, or it'd be big enough. So mine's not going to be that big. So I'm going to go to 2, 4. And what kind of circle or dot am I going to put? Circle or dot? Why open circle? No equal to mark, so that's open circle. Now, what do we know about the graph of x squared? What's it called? Start with the parabola, okay? And we know it's going to make that U kind of looking shape. So what do I know the vertex of y equals x squared is? 0, 0. How else could I find that point? Plug a 0 in for x, right? Because 0 is less than 2, right? And I could plug in -1 and get an ordered pair. -1 squared is 1. I could get that point. I could plug in -2 and get +4. Oh, messed up. There you go. And then I can plug in -3 and get 9. 5, 6, 7, 8, 9. So I get a real good picture of what's going on with that particular part of the graph. And it's got an arrow on the left side because it's all the x's that are less than 2. So I get that picture for the first part. What's the important point for the second part? Two, -1. Yeah, plug in 2 for x. Get -6 plus 5 is -1. So I'm going to negative. Then am I going to put a dot or an open circle? Open, because it doesn't have an equal to mark. And then it follows the line -3x minus 5. So I know that just is down 3, right 1. Or I could do what? Plug in some x values that are greater than 2. I can, if I don't know that x squared is a parabola, I can still get that same picture just by picking x values and plugging it in. I can get the idea of what it's doing. So if you ever just don't remember what a picture looks like, just plug in some x values. You'll get some points, and you'll start seeing the shape happening there. All right. So let's talk about the domain of that. Read it left or right. So what to do? Negative infinity. So I'm going to go in here, and then right there at that spot, what's happening? Stops, and 2 is not used. Is 2 used on the blue part? Oh, so we're skipping 2. So we go from negative infinity up to 2, skip 2, and then the blue part continues on forever toward positive infinity. So there would be my domain for that. And if you look at the domains up here, x is less than 2 and x is greater than 2, that if you put that together, that really is exactly what we wrote for the domain by reading the graph. It's the same thing. So you can get the domain without drawing the graph. The range, you could get it without drawing the graph, but it would take a good bit of thinking on your part and visualizing, and basically you're visualizing the graph. So I just graph it to find the range. So what's the range? So to get from negative infinity and go up, right? So we're going on the blue line right now. We're riding up that track. And it stops at -1. And does the red one use the -1? Does it cover it up? No, it doesn't. So we're skipping something from -1 to where? Where's the next y value that gets used? At 0. And is 0 a bracket or a parenthesis? Y bracket and not a parenthesis. You know, it's a solid point, right? So, and then it goes on up to infinity there. The left-hand side of that graph goes up to infinity. The right side stops at a spot, but the left side covers it up and keeps going forever. So there's our range. Intercepts. 0, 0 is the only one we have. And then is this continuous or discontinuous? Discontinuous. Because we had to pick up our pencil to trace it. Okay. One more thing with this example. Find f of -5. How do you do that? Okay, but there's two pieces to that function. Which one do I plug it into? Why? All right, so -5 fits the first inequality, so that's why we're going to use the x squared to find that function value. So f of -5 is -5 squared, which is 25. If they ask us to find f of 10, which one do I use? The bottom one, because 10 is greater than 2. So that's where we're going there. So -3 times 10 plus what, 5? Is that what it was? Plus 5. So that'd be -25. So function value with piecewise defined functions, you've got to just basically figure out which piece to plug into using the inequalities that they give you. So be careful of that. They always kind of pick some weird values that are kind of tricky. All right. Let's do one more. We got time to do one more. G of x is equal to, and we'll do something a little less. So a square root of x minus 3 is the second piece, so a square root function. So let's start with the first piece. Important points. How many of them are there for the first piece? 2. So we're going to have it -3 something and 1 something. What's -3? What's the 8 and 1 4. All right. So on my graph, I'm going to those points And what do we know the shape of 5 minus x is? It's a straight line. And so -3, 8. Put a dot there. And then at 1, 4, what am I going to put? Open circle, because it doesn't have the equal to mark there. And I'm just going to connect those two with a straight line because I know what that's what it looks like. If it wasn't a straight line, but I didn't really know what it looked like in between those 2 points, how could I find the picture? Plug in the x values between -3 and +1. That would get me the idea of the picture. You plug in x values anytime to get the picture going. Okay, second half. Important point at 1 something. What's the square root of 1? 1. 1 minus 3 is -2. So I'm going to go to -2, 1, -2, and put what? Open circle. Now, how many of us know what the square root of x looks like, graph-wise? Is anybody? Okay, good. We don't know what it looks like. How can we get the picture if we don't know what it looks like? Plug in points. Plug in x values. Plug in 2, 3, or I'm going to pick numbers that have nice square roots. So 4 is a good one. Square root of 4 is 2. 2 minus 3 is -1. So I'm going to go to 4, -1. And then the next one that's got a nice square root would be 9, right? The square root of 9 is 3. 3 minus 3 is 0. So 5, 6, 7, 8, 9. And then the next one would be 16. And that'd be 4 minus 3 is 1. So that's going to be somewhere out there. Here's the idea. Here's the picture is kind of a curve out of that. If you were to graph with your calculator, we'll clear out this other junk. The square root of x minus 3. That's what the picture looks like. Now we know we're going to cut it off early at we're starting here. We cover up that part. That's what the picture that we're trying to draw looks like. It's a little curve to it. It's basically the one side of a sideways parabola is what that graph looks like. Okay. All right. So from there, let's get the domain. To what? To +1. What's not included? What about the 3? The -3. So a bracket there. And then what? What to positive infinity? 1 to positive infinity. Okay, so there's our domain. Range. What's our lowest y value? Is it included? No. Now this is the tricky part. So this red line, the highest point here is 8, right? But what does this one do? Keeps going. It's going to take it a really, really long time to get up there to 8 or above it or past it, but it's going to continue to go up and to the right, way over here, right? So the range would go to where? Positive infinity. So that was a little bit tricky on the range. Intercepts. Nine, 0. The blue line there. Now, my red line is not real great there. I know it crosses at a little better spot than that. Where's it cross at? How do you know 5 is the right number? Okay. Okay. That's fine. Yeah. And then also, how else could we find a y-intercept? Plugging in 0 in for x, and which piece do we plug a 0 into? The top one, because 0 fits in that inequality. So anytime you need to find a y-intercept, you can plug a 0 in for x and not have to have the whole graph to get there. All right. All right. So that gets you piecewise defined functions. Tomorrow is a work day. Page 248, 9 through 49. The odd ones, if you have trouble with them, the even ones beside it are always good to look at as well. Just a lot of piecewise defined functions. There's going to be several different functions kind of mixed in there. Get you a good idea of that. If you look through that section, there are some descriptions of different function types in the notes part of that section that might be good for you to familiarize yourself with. It'll kind of help you when you're doing the piecewise with those individual pieces out of that. Okay.